Go ahead. All right. So, hi, I'm Mackenzie. This is Patricia. We're going to be talking about what to do with the organic waste that's generated on campus. So there are just under 50,000 students enrolled at UCLA. So that's quite a bit of people. They generate a lot of waste, especially given the amount of food that essentially is wasted across the country every day. So as was mentioned in the previous presentation, 40% of those students are food insecure, meaning they either don't have a variety in their diet or they don't have the money to buy the next meal they're going to eat. And then also me and Patricia went up to the hill where most of the students live in dorms and looked through some dumpsters, and you'll find all of this wasted food from either the back of the house, the kitchens, or from those trays that go down the conveyor and disappear after leaving a student's table. All that food gets pulped. All of that food gets pulped and then thrown into these green bins that get emptied every day, and 309 of those bins are emptied every single week. So basically what we did was we started by taking data from Athens Services, who currently takes all of our green waste, and putting that on the map of the campus so we can identify where are the big producers and where would it be best to collect the compostable material. Because it's not just about how to compost, but the logistics of implementing said composting project. So we generate over 10 million pounds of compostable waste every year. And as you can see, it's concentrated mostly in the hill area, and then a little bit over here wherever we have a kitchen, like the faculty center, and then a little bit in South Campus where we have some labs that generate a lot of animal bedding. Now this is including food waste as well as things like yard trimmings, grass, etc. But most of it, the majority, is food waste. But as I said, those are green bins that are being picked up by Athens Services, meaning it is being composted presently. But if you look at, say, where our landfill is, which is right over there, it's kind of cut off, but that's 35 miles away. So some of the yard trimmings get sent there as alternative daily cover, meaning they throw it on top of all the trash before they add in the next load. But our composting facility is 105 miles away. So if you use the EPA's way of estimating the energy and carbon footprint of different waste disposal methods, we are, by trucking all of our waste every day, 105 miles away, we're generating 843 metric tons of carbon dioxide a year. And then if you think about how much money we're spending on having Athens Services take our green waste there, it's substantial, okay? So one thing that we're thinking about is to bring that local. Is it feasible, and how difficult will it be? How much manpower will it take, and how much will it cost? So one way to do this is using an in-vessel composting unit, which are commercially available. So we shopped around and we found Food Organics and Recycling Solutions, which has multiple sizes and types of in-vessel composters. So basically you put the compostable material into a large grinder and along with a bulking agent, and then that can be pushed through the system, and the natural bacterial processes of breaking down food is accelerated using heat, and then at the end you have compost that comes out the other end. So we talked to some of the experts at FOR, and we learned about what can and can't be put through the composter. For example, hand towels from the bathroom, not good because the antibacterial soap could harm the bacteria. But we also found a lot of the recycling on campus is actually cardboard, which can be used as an alternative bulking agent to, say, wood chips. So taking that into account, along with the types of waste in different areas, along with the manpower and the different models, we're hopefully going to be able to bring composting to the campus. Now, if you look at how we're going to pay for it, these units, like the one shown in the middle, cost between a couple $100,000 to $800,000 a piece. And that doesn't necessarily include maybe the different staff that would be taken to implement it. But if you look at the previous, or if you remember the previous figure, what we're paying Athens to take it away is significant in and of itself. So if you look at the different models that they offer, and which come in different shapes and sizes, and if we minimize it down to just what we would need to take care of waste on the hill, which is very clean green waste that's produced, we could, right now, if just on the hill and just the green waste, this isn't trash or recycling, we're spending about $27,000 a month for Athens to take it away. If we were to do a lease-to-own option through the in-vessel composting company FOR, we could be spending $33,000 a month instead for the hill, and that would end after 7 years, and we would have all the infrastructure to process the green waste here on campus. Now, there's a lot of other questions that go into it. Like we said, the logistics and what types of nutrients are where on campus. How are we going to get the stuff into the grinder? But we believe that it is somewhat feasible and mostly more environmentally and economically friendly than what we're doing presently.
So as Mackenzie mentioned, we really need to take in consideration what we're putting into these composters. In order to get an optimal compost, you need to have a carbon to nitrogen ratio of between 25 to 30 parts carbon for every 1 part of nitrogen. So what we did is we went to we calculated based off of what was being put in each bin on campus and on the hill, and we figured out how much of that is considered carbon, how much of that is considered nitrogen, and we calculated out how much extra bedding we would need in order to get a high quality compost. So from that estimate, we found that about 76% of what are currently producing on the hill is carbon, about 4% is nitrogen, which once you do the carbon and nitrogen ratios, it's actually pretty close to what's optimal. And then we add in about 20% bulking agent. And what's also important with the bulking agent is that it helps to aerate the compost. So in that way, we can get a high quality compost, which could be used in the community rather than just generating waste and trucking it away. So once we know what's going into this, we want to take into consideration where everything is and how best we can service our campus. So in this map here, for the sites that I have circled, I did my calculations based off of these really high producing sites. And we need a minimum of 4 composters to be able to get rid of all the waste that are on these sites. But instead of necessarily having 4 really giant composters, it might also be more advantageous to have smaller units that are at specific locations. So for example, instead of having to transport something from the dining hall to a localized site, we can just put it all in waste contained in the composter that's at the dining hall. So we also want to extend this analysis to the entirety of campus. So I also included these high waste producing areas. And once we take all of the composters that we would need across campus and compare that to how much we're already paying to truck the waste away, we find that we're paying about $54,000 a month to truck all of the organic waste away, just getting rid of it. But it would cost, for the entirety of the campus, $55,000 a month to be able to have enough composters to deal with all that waste locally, which, if you consider only over 7 years and they're already a comparable monthly fee, this seems like a really feasible solution financially and environmentally. But one of the big considerations when you're dealing with a campus like UCLA is going to end up being how much space you have on the campus. Because, we're a really dense area, there are a lot of buildings, and we want to be able to build really big composters. But as you can see here, where a lot of this waste is being stored, it's not a lot of space. So essentially, part of our consideration is we need to determine what are ideal sites where we can take the compost, but where there's enough space to be able to service specific areas. And part of how we're dealing with that is potentially just using the smaller composters because they take up less overall space. And the smaller composters also really help with the transport issues. So when we're taking waste from one location on campus to another location on campus, that's a lot of manpower. We're not going to have a company like Athens moving it around for us. So once we think about solutions where we have more smaller composters, that helps with the space problem and that helps with a more localized transporting problem, which in my opinion is a much more feasible solution for how we can deal with the compost on campus. Now, once we have composting facilities, there's a shift in thinking. So instead of generating something that we consider waste and we just want to get it all off campus, we're producing something that can actually be used to give back to the environment. It can give back to the community. It can give back to surrounding farms in the area. So in a preliminary search, I was able to find that within a 50-mile radius, there's at least 5 major big-sized farms which we could contact and see if they would be interested in utilizing compost. Obviously, we would want to keep some of it on campus so it can contribute to the edible food project. It can contribute to the VA garden, which is close by. And also, to remind you, composting, as well as producing nutrients, it helps with water retention. So that also helps to contribute with saving water in a drought environment. It helps with reducing the amount of weeds, and it also stabilizes the ground. So when you have a lot of rainwater, you wouldn't get as much flooding because it stabilizes some of the earth. So, yeah.